Now, last lesson I left you off with how I determined where the post and the beams are going to be to support this deck. Now, this is a challenge. We're looking at a two-dimensional plan here. I have two different colors separating the different levels. So the magenta color is the deck level that is one step down from the blue color, or the blue portion of the deck. So imagine, if you will, we've got a beam that runs along the length, and it's supporting an upper deck and a lower deck. And we're going to draw this detail, but essentially what happens is this. The blue portion of the deck sits on top of the beam, whereas the magenta portion of the deck, being lower, actually ties into the side of the beam. So we'll be using joist hangers to tie the pieces together for that portion of the beam, where over top we have a different type of connection to make sure it's secure. So all of these different things have different connections. So for instance, there's a board that runs along the edge of the deck which attaches to the house. That's commonly referred to as the ledger board. And that board gets secured right through the house into the framing below. Now there's all sorts of requirements behind that, whether it's aluminum siding, wood siding, whether it's brick, veneer, stone, or if it's concrete. There's different methods of connections, and we have to try to understand the different methodologies. Now, for the purposes of this program, we're going to explore one or two, but it's really going to be site experience. I know from my 4 years of architectural design training as a technologist, I really didn't fully understand until I went to a job site and saw it, and actually went through the process, and then it kind of sank in. So it is theoretical at this point, but we need to get some basic ideas of how this connection is actually going to happen, because we have to respect the existing construction, and we can't do anything to damage or hinder it or cause it to, for instance, leak, because we've actually gone through the surface material that's designed to protect the house and gone into the actual home itself. So those are things we're going to look at. Simpson Strong Ties is where we're going to begin with this. So I'm just going to pull up some images that I have here for you to review. And these are all catalog items that are part of the folder collection of lesson number 5. So the first one here is the complete connection system for buildings. So this is right off the Simpson Strong Tie website, and it talks about two different levels, the deck level and then what's basically below the deck level, or in the case of a pergola or something of that nature. So these different connectors, and I throw this in now, even though you're not going to really specify this until much later on, you have to become familiar with these connectors. What do each one do? Like a standoff post base goes from the concrete sonotube to the post. Now, you may not have a post here. You may have it right onto a beam. So it requires a different type of saddle connection for that type of assembly. Then we have our framing that goes from, let me zoom in on this so we can see it a bit better. We have our framing that goes from the joist directly to the beams, sitting on top. That's the one detail. The detail I was talking about earlier is we're actually going to have joists that come right into the side of the beam. So the two decks actually lean on, one on top of the other, or they rest one on top of the other, but they actually don't. They're connected to the beam in two different ways. So the connection down here is very similar to what we do at the house with the ledger connection. And the house connection, once again, has its particular elements that you must be aware of. There's connections with how we deal with handrails. Now, I've got a separate document for that. It's the exterior guard detail document called SB7. It's generated by the province of Ontario, and it's basically cut and paste. You pick your different elements and you cut and paste the PDF file into your drawing, and you're done. And it meets specific guidelines. Now, Simpson Strong Tie has connections as well, but we're not going to use that. We're going to be using the SB7 document. That's also part of Lesson 5 documentation. And then down below here, let me just scroll up here. We also have different connections between posts and beams. These are another type of ledger, as well as when we get into the pergola. Now, some of these are really not attractive, let's just put it that way. But they do have a whole section in their catalog of very attractive connections as well, and that may be something that we'll look at decoratively. You can see here where we have a step, I used in my example coming off the dining room, I have a step. Basically, you're building a deck on top of a deck, that's all. And that's what they've done here as well. So we'll look at that. The other document I've provided here is called the F Deck Code 20. So it's a brand new document for 2020. And again, it goes in a bit more detail with the connections and what they do. You don't have to study this, but you need to be aware and familiar with all the different parts and pieces of it, because we'll be looking at them, and eventually in your final project you'll be specifying them. So a lot of this I'm showing you now as different visual effects of the deck. We have to become very familiar with the three-dimensional aspects of the deck. So for instance, the board that runs along the house is called a ledger. The board that runs along the front as well as the side, we're going to call rim board. Sometimes there's a couple of different names for it, but the rim board is basically, as the name would describe, the outer rim of the deck. And the interior components are the joists. So you can see here very clearly that this inner joist and the last board are exactly the same. So we do floor joist calculation for it, but the outer two floor joists are called the rim board. And you'll see in this document, like I said, it's far more precise. It gives all sorts of details of different connectors, including the one towards the house. Like I said, we're not going to spend too much time on that. You need to understand that this connection, though, is extremely important, because what you're basically doing is attaching the deck to the house, and the house is acting like a beam. So when we do our calculations, where we looked at the last example, we know that the 2-foot overhang is part of the calculation for the beam underneath it. But the rest of the joist itself, we were dividing it to two, and the one half gets attached to the beam that you see. The other half gets attached to the house. Now, there's no beam calculation for the house. The house is strong enough to carry any of those loads. It's designed to carry the maximum load, as long as this joist is less than 16 feet wide. So it's more the connection that we're concerned about than the actual structure of the house, whether it's strong enough to support it. It is. So that really doesn't become part of the calculation. But we do have to calculate halfway along that length and the overhang for the beam that supports underneath. So once again, these three-dimensional images will hopefully help you visualize what it is we're going to be doing with our project. And there's other things like cleats for stairs, steps, offset posts, but it's a good document to go through and become familiar with, because it has all the different deck connections, and most of these you can buy at Home Hardware, Home Depot, Lowe's, or anything like that. Their boxes are actually labeled Simpson Strong Ties, so you should be able to find each and every one of them. They also have a software. Now, I haven't explored the software, but regardless of a software that automatically does a lot of this calculation for you, you need to understand what the parts and pieces are before you can move on and use a software of that nature. So once again, this documentation is for your review. It's to help you with further on in the project how to actually make all the connections as part of the documentation and include them in your drawings. I'm going to show you how to go through the process. You know what? I'm going to pull that up right now. Let's see here. So once you define a connector, let's say for instance you're connecting a beam or a joist to a sonotube, you'll then look it up on their website, and here's the connector there. And then on their actual website, they have CAD drawings. So if we click on the CAD drawing, we actually have the drawing specific to that particular item. So I know that I was looking earlier, and I want a, I think it was an ABZ 8. And if I go down here, I can eventually find it. I may have to pull up one of the other ones here. Okay, where are we here? ABW, maybe it was an ABUZ or 8, and there it is. So with that one, they have perspective drawings, and we look at DWGs, their CAD drawings, and we can actually download that image. And like any of these downloads, if we select them and they pull them up, we can then use, it says it's no longer available, we can then use it in our CAD drawing. And it's just a copy and paste, as we've used before in the first year of the CAD program. So we're going to look at that later on, but just be aware that it is here. Why am I doing this now? Because I want you to become sort of familiar with repetition of all these different elements that we're going to be looking at through the program. So I'm just going to come into here and show you a typical town requirement. So when you actually, in this case it's just Aaron, which is close to me here, if you go to the local building department, they'll tell you what they're expecting in their permit set. So this is giving you the minimum requirements before you require a permit and all that, and then showing you how to lay out the deck. This is particular to decks and exterior guards. They're looking for the framing, how we actually note the framing, the sizes, the drawings, the sections, the elevations, anything to do with staircases. So this is the level of information. Now some of the details here you see are actually from another document that once again you cut and paste. So we don't have to spend a lot of time drawing this, but we do have to spend the time to actually find it. So this is the town requirements, looking at the exterior guards and decks for houses. I've also included in Lesson 5 the Exterior Guard Detail SB7 document, which looks like this. And this one, it's not that complex to go through. It's basically a series of tables and charts that you then decide based on your spacing what you're going to pick. So I'll give you a very, very quick example. Once again, we'll do some more detail on this later on. This talks about rails, handrails, floor posts, infill pickets. So you've got an EBA or EA document, an EB document, and an EC document. You have to have one of each. And the one talks about the rails, one talks about the posts, and one talks about the pickets. And so depending on your spacing that you have on the deck, like here's a very simple one, and I wouldn't expect you to pick an AA document because this is so simplistic. It would really look horrible on a deck. So let's pick something a bit more interesting. Let's go down into an EA3 document. And this example shows you that you can actually have spans of up to 8'11". Now, SPF lumber is the one we use, spruce pine fir, and that's why I went to 8'11", not 7'2". 7'2" in northern species, which we don't have available here. But this says I can have posts at maximum 8 feet 11 inches apart if I use this design connection. So that would be our EA document, how the connection looks and works. Then we look at the post connection, and here I would decide based on how I want to frame this into the deck, what post connection I want. So for instance, I may look at this and say, you know what, this is the way I'm going to frame each of my posts, which I believe is the way I've actually drawn on my own project. And here it shows you that you can have a maximum post spacing of 5'11". So even though the handrail spacing can go up to 8'11", the post spacing in this case can only go to 5'11" if you've connected it this way. And you don't have to do anything, like I said, in terms of a drawing. Just copy and paste this basic PDF file right into your CAD drawing, and you've now spec'd how the posts are going to be connected. And whether it's for posts or screens, you're going to use a similar system. And there's examples for different applications, different installations. Some of them have larger spans, some of them have smaller spans. So you define your handrail, you define your posts, that's in this section, and then you define your picket arrangement. So you may look at this and say, I want pickets that look like, for argument's sake, this one here. So what is this? This is an ED2 document. So you basically have 3 different pages, cut and paste into your final example. So I've included this here. It should be reviewed. All this information you should go through to know where it is, because when the time comes to actually do it, you won't have a lot of time to find it and paste it in. But also, as we're framing, we have to think about these things. We have to think about all the different elements. It's like any course. The second time you go through a course is much easier because you've got all the parts and pieces. Well, we need to know what is kind of available to us, or if we're stuck on part of the problem, where to go to find an answer. Even though we're just framing at this point, we have to understand how we'd frame all these different elements together. So I'm going to close this down, and I'm going to close this down, and we're going to go back to this drawing to talk about framing.